Numpy, which stands for numerical Python. Why is this so much important in data analytics, machine learning, and data sets? Why we always prefer NumPy array over Python list? Let's figure out. Hi, I'm Prashant. So today in this video, we'll talk about the powerful library of Python that is NumPy. What is NumPy? NumPy is used to create n-dimensional array object, which is much faster and memory efficient than Python list. Why NumPy is so powerful? NumPy is so much powerful because it supports vectorized operation which runs much faster than Python loops. It is more memory efficient, stores data in contiguous memory. It is more convenient and it supports mathematical and statistical functions. NumPy is the foundation of other libraries like Panda, Scikit-learn, ML framework, which are built on NumPy. Now let's understand the difference between NumPy array and list. So first of all, we'll check the speed of Python list and then we'll check the speed of NumPy array. Then we'll do the comparison here. So first of all, I will import the library, import NumPy as LP, and also I will import the time module. I will create the list here. So here I'm creating a list of numbers up to 1 million. I will also check the time here. And I will perform the list of operations here using list comprehension. So what I'm doing here is I'm multiplying the list of numbers up to 1 million by 2. So this is the speed we got of creating a numbers between 1 to 1 million of list. So this is the time we got, that the time is in the second, that is 0.18 second. Now let's check the time and speed of NumPy array. So I will create the array here as ARR equals to np.arange. I will also initialize this time. Now I will simply multiply array by 2 and I will check the speed here. Now I got the speed of NumPy array as 0.0049. So this shows that NumPy array is much faster than Python list in terms of performance and speed. Okay, now let's see how memory efficient NumPy array and list are. So first of all, I will import the module import sys, and now I will create another list, that is lst1 equals to list range up to 1000, and I will also create an array, that is arr1 equals to np.arange up to 1000. Now I will check the memory size, each of them. List size sys dot get size of lst1. I will also check the size of array, that is numpy array size. So I will use arr1 dot n bytes. So first of all, I will run this one and I got the size of a list, that is 8065. And if I run this one, So I got the size of 4000. So this shows that NumPy array is more memory efficient as compared to Python list. Now let's understand the practical examples of NumPy. NumPy is used to create an array to perform vectorized operations, aggregations, reshaping arrays, Boolean indexing and slicing, and random modules, which is the foundation of machine learning and simulation. So let's understand the practical implementation in our Jupyter Notebook. So I have already imported my library NumPy. So first of all, I will perform some operations, some vectorized operations in NumPy. I will create one array, that is mp dot array, and 1, 2, 3. So very basic array we have created. So I will create one more array, that is b numpy dot array. I would we create another array here, 6, 7, 8, 9. So let's do some vectorized operations here between the two arrays. So first of all, I will perform a plus b. So I got the result, that is 7, 9, 11, 13. So by simply using the addition operation, we can add the two arrays. If I need to multiply the two arrays, I will simply use a multiplied by b. So I can easily multiply the two arrays. So let's do some aggregation in NumPy. So let's create first of all an array, that is np dot array, and I will use 10, 20, 30, 40. So I have created one array here, and if I need to do some aggregation in this array, I will simply use data dot v, and I got the weight of this array, that is 25. And if I need to sum the all the elements of this array, I will use data dot sum. So I got the sum of these arrays 100. I can also calculate the standard deviation of this array. So I got the standard deviation of this array is 11.218. So let's do some random modules. So if I need to create some random numbers using random modules, so how I will do that? Random. So I will create another array, np dot random dot rand int, and I would use 1 to 100, comma 5, and I will run the other statement. So we got 5 numbers, which is between 1 to 100. So with the help of random modules, we can create any random numbers array. All right, now let's see the conclusion of this session. NumPy array is much faster than plain Python list. It is more memory efficient. It is more convenient and supports mathematical and statistical functions. It is the foundation of Panda, scikit-learn, machine learning, and other libraries. All right, thank you so much for watching this video. I hope you have enjoyed this session. Have a good day.